Hi, I'm Guru Rajan. This is part 4 of our series Detailed Introduction to Design Patterns. In part 3, we looked at the benefits of design patterns and the different kinds of design patterns. Now, let us find out what kind of design problems also are solved by design patterns or solved by using design patterns. Now, let's look at the first one. You would agree that one of the most difficult tasks in object-oriented design is to first decompose a system into classes and objects. This very decomposition has a lot of things to be considered in this. How granular you should go, what kind of dependence and flexibility you should have between the classes and objects, what is the compile time structure going to be, what's the runtime structure going to be. Lot of these things need to be considered in finding appropriate objects. Finding appropriate objects, you need to consider so many things in bringing to this, in bringing a structure for this. And design patterns help us to see very non-obvious abstractions, such as an algorithm can be considered as a class. In visitor design pattern, behavioral design pattern, you talk about double dispatch, where an operation will be called based upon the name and two receivers. Usually in single dispatch, the operation that's going to be called depends upon the name of the method and the type of one receiver, whereas in double dispatch using visitor, the operation that's going to be called depends on the name of the operation and the type of two receivers. So this idea can be obtained only after you know the behavioral design patterns, specifically the visitor. Even a process or a state can be modeled as a class. These are non-obvious abstractions which you can think while designing your system. Now, what is the granularity of your objects? How many objects should you create? How to decide this? Well, do you want to have the entire system as a class, or do you want to have very small things such as even a chip or a particular pin of a circuit as a class? Now, what's your granularity going to be? To decide this, patterns such as facade granularity, object granularity can be decided, or some idea of this can be obtained if you look into the design patterns. The other design benefit you get by using design patterns is what kind of things you want to put in an interface. What do you want to put in an interface? What kind of data you want to put that will be sent across the interfaces. Now, the memento design pattern is an example for this. And how do you specify relationships between interfaces? The proxy, decorator are all examples of how object instances can be specified and what you put in an interface. So, what you put in an interface. Okay. Now you could understand how to decompose a system into classes and objects. You could understand the object granularity. You could understand what you put on an interface if you understood design patterns, or you could get an idea of that. And one of the most important thing once you have built a system using the structure and the objects is how do the different classes and how do the objects communicate with each other at runtime. You know, by looking at the code, you cannot tell how the program is going to run. That's because this is runtime polymorphism is involved, and even single dispatch or double dispatch is going to be involved. So how the communication between the objects take place, the runtime structure can be understood by using design patterns. If you used visitor, or if you used a state or a strategy, you would immediately recognize by looking at the compile time structure, you could guess that this is what probably could happen in runtime. So this idea of compile time structure versus runtime can be understood better by knowing the design patterns. So these are some of the design problems that are solved by using the design patterns, or rather understood better. So these are the things that GOF talks about the design problems that you could appreciate better, like finding the appropriate number of objects or object granularity, or the flexibility you will get in over design, and what you need to put in an interface, and understanding better the compile time and runtime structure can be done very well with the knowledge of design patterns. So we got an idea of what kind of design problems are helped to get solved if you use design patterns. In our part 5 of the video, we would look at one single behavioral pattern, which is state, and completely explore them. And we would also look at a C++ implementation if we can. Thanks a lot for watching this video. Have a good one.